As you may know or have probably guessed by now, the games in game theory are not really games, but real life situations with different participants or players, where each of the players has their own strategies to play. These strategies or combination of strategies have outcomes or payoffs, benefits or losses for each of the players. There may also be a few rules or constraints to a game. Game theory tries to find out if there are stable and optimal strategies for the players in each of these games. Let me first give you a very brief background and history of game theory. Although many scholars have written and analyzed particular situations of conflict and cooperation before, game theory did not really exist as a unique field until John von Neumann published his paper on the existence of mixed strategy equilibria in 1928. This was followed by his 1944 book, Theory of Games and Economic Behavior, co-authored with Oscar Morgenstern. In 1950, the first mathematical discussion of the prisoner's dilemma appeared in print. Around the same time, John Nash developed his theory of the Nash equilibrium applicable to a wider variety of games. Game theory experienced a flurry of activity in the 1950s. Repeated games, the Shapley value, and a bunch of other concepts were developed. And the theory started to be applied successfully to several real life problems in philosophy, economics, and political science. The game theory scenarios or games can be classified in many ways, and here are a few just to give you an idea. One broad category of games is zero-sum and non-zero-sum games. In zero-sum games, for someone to win, someone else has to lose, usually by the same amount, so that the sum of wins and losses equals zero. Non-zero-sum games don't have this criteria, so there can be a mix of conflict and cooperation, and it is possible for multiple players to win or lose. Another classification of games is cooperative or non-cooperative games. In cooperative games, players cooperate and have joint strategies, sometimes with externally enforceable or binding agreements. There is no such cooperation, collaboration, or joint strategy in non-cooperative games. There are several other ways to classify and categorize games as well, and you can read up further if you're interested. In this course, we will be looking at several situations of interdependence, conflict, competition, and cooperation. We will look at several economic and socio-political games and analyze them. We will also look at successful and not so successful strategies that help in such situations and take practical lessons from them. Don't worry, this will not be a complicated game theory course with a lot of formulae, equations, and probability curves. This is an introductory course on basic game theory strategies. The only math you will need is high school math. If you are interested in delving a lot deeper into the complexities of game theory, there are a lot of other courses and books that you can refer to. Okay then, shall we get started?